Let's see. I think we can start now. All right, let's see. We have we go to the table and then put the table in. From here, we can look at the required probabilities. You say n is 10, it's a 10 right here. And I'm trying to share this. Okay. It's not coming up. Just give me 1 minute. Let me put this together. I wanted to open up this, but it's not coming up. Okay, we have here. Will this one work? Okay, since this one is working, this one should work. Okay, now you can see it. So, probability of we're looking for probability of at least, so at most 3. At most 3 will be this is 3 right here. This is 10, and this is 3, and P is 0.4. So you go all the way from P all the way down to 3. So 0.4 to 3, which is here. That's where you start. You can see just 1 minute from 0.4 to 3. See 2 is right here. Yeah. So now you can see the 3 right there. So at most 3 means this one here for 0 plus this one for 1 plus this one for 2, and then the last one is 0.215 for 3. So let me write them down. 0.06 plus 0.040, as this one here, 0.040 plus 0.121 plus 0.215. So when you add all this, that will give you the probability of at most 3. I mean, from 0 to 3. So let me take you back so we can put them in. So we have equals, oh, I think I should put it under them. Okay. Okay, equals 0.006 plus 0.040 0.040 plus 0.121 plus 0.215. So we add all this. That will give you the probability that at most 3 will marry within 3 years. So let's add them up. We go to Desmos calculator, and then we can say it, clear this up. So we have 0.006, 0.006 plus 0.040 plus 0.121 plus 0.215. That's give us 0.382. 0.382. 0.382. So that we have the answer as 0.382. Or if you like, you can call it 38.2% chance that at most 3 will marry within 3 years. So look at this. Remember, this is the question about the probability that a divorcee will marry within 3 years. And we are given the P to be 0.4. And we are told to use the binomial table. And also, we are told that there are 10 divorcees we are choosing at random. Now, using this table, like I said, you can see how it simplifies the process. Otherwise, we would have used the formula to find this probability. Find this one, find this one, find this one. That would take a lot of time. But with this formula, you can see how simple it is. Let's try the second part, which is part B. Part B says, it says, at least 7 will marry within 3 years. At least 7. So remember, our N is 10. As 10 divorcees were selected. So N is 10 and P is 0.4, which we are given 0.4. So at least 7 means 7 and above. So it's 7 to 10. So that our X will be equals 7, 8, 9, 10. See? So that the probability of at least 7 okay, becomes the probability of 7 plus the probability of 8 plus the probability of 9 plus probability of 10. Yeah. Now, why do we stop at 10? Because our only 10 divorcees were selected, so N is 10. So at least 7, it means 7 to 10. Okay. Now, so now we can figure this out by looking at the table again. Our N is 10, our P is 0.4. We start from there and then go from look for 7 to 10. These days they have cumulative binomial probability table that can give you this cumulative answer. But that's not the one we're using. So N is 10 again. You can see the 10 right here for N. See the N 10. And P is 0.4. So 7 to 10 gonna be from here. You can see right here. See the 7 to 10. Okay. See, this is 7 right here for X. 8, 9, 10. So that means you're gonna go from here, pick this one out, pick this, and that. Let me write them out down. The first one we're picking is 0.042, 0.042 plus. Next one is 0.011, 0.011 plus 0.002, 0.002. Then last one is 0.000. That is the 10th for the 10. Now we can now go to our calculator and then add them up. But let us write them down first. These probabilities from the table will be 0.042 plus 0.011 plus 0.002 plus 0.000. That will give us the answer. So let's do it in the calculator. You can add them from there. So we have 0.042 plus 0.011, okay, plus 0.002, okay, plus 0.000. Of course, that one is you know that is 000 is 000 is zero, not nothing is it's just a placeholder. That gives us 0.055 0.055. So I have it here, 0.055, or if you like, I can call it 5.5% chance. So this is how you use it, answer such this kind of problems. When you are using a table, it simplifies the whole process. Now let's do part C. It says from 2 to 5 will marry within 3 years. To find that probability. That's part C. So in that case, X equals 2, 3, 4, and 5. So that the probability that from 2 to 5, 2 to 5 will be equals to the probability of 2 plus the probability of 3, okay, plus the probability of 4 plus the probability of 5. So you're plugging this in into the formula in the table. Go to the table and look for them. And so 2 to 5. I'll take you there now. 2 to 5. Again, N is 10. P is 0.4. So 2 to 5. You start from the 2 right here. Follow it under 0.4. It's right here. So this is 2 right there. Okay. 2. So this is 2, 3, 4, 5. Okay. So 2 is 1 to 1. Okay. So that'll be 0.121 plus. The next one was 0.215, which is this one here. 0.215 plus. The next one will be 0.251. 0.251 plus. Last one, which is for 5. You can see 5 right here. So it's gonna be 0.201. 0.201. So we add all this. That will give you the required probability. Okay. Let us write it down first. So it's gonna be 0.121 plus 0.215 plus 0.251 plus 0.01. So that will give you the required probability. We can now add them up using the calculator. And that's give us 0.121, yeah, plus 0.215 Okay, plus 0.251. Okay, plus 0.201. So 0.787. 0.787. Yeah, 0.78. Oh, I forgot to put 1. 0.788. So 0.788. Let me correct it. 788. So now I can take you to put the answer in. 0.788. Okay. Just 1 minute. Let me make sure you're seeing this. 0.788. Or if you like, you can call it 78.8%. Now, so or 78.8%. So now, part C, you can try as a practice at home, just for your practice. Let's round up by discussing the mean, variance, and standard deviation of a probability distribution, of a binomial distribution. So I'm going to write the formula down, and then we use the an example from the book. So one example, like I say, I always like to use the application question to answer it. So now the mean, of course, is the average. So I'm going to write the formulas here. I'll take you to the other workbook, and then we can now get the mean, write them down, and then start solving some questions. So the mean for the binomial, the mean mu, which is the Greek symbol we use to represent it, mean, which is the mu, equals n times p, okay, n times p. Yeah. May copy it and paste it there so you can see it. Okay. The mean is n times p. Okay, n times p, make it bigger. Let's take the variance, and let me put the formula for the variance. Get it from the second workbook. The variance, which is delta squared. Okay. Variance is delta squared. Okay. Equals n times p times q. N times p times q. Okay. And that's the formula that I'm going to put here so you can see it. N times p times q, which I can make it bigger. Okay. Then standard deviation is just the square root of variance. Standard deviation. So we have standard deviation, which is the delta symbol that we use for standard deviation. Oh, my mistake. Delta symbol equals to the square root of variance. Variance. Okay. Now with this, we can round up by solving one question that involves finding the mean, variance, and standard deviation. I mean, there are many examples that you can try, but let me start with this one, the application example. So you can try these ones here at home, all you have to do is to for the mean multiply 100 times 0.75, and for the variance, it said you find the Q. Q is 1 minus P, which is 1 minus 0.75. That will give us 0.25. Then you multiply all. That will give you the variance. Then the square root of that will give you standard deviation. So you can practice this one there. It's pretty much easy. Now, but the one I want to show you is an application one, like this one here. It says the statistical bulletin published by the Metropolitan Life Insurance Company reported that 2% of all American births result to twins. A random sample of 8,000 births is taken. Find the mean, variance, and standard deviation of the number of births that result to twins. Solution. First of all, we find our values for mean, for n. Our n here is set 8,000 births. We are selected, so 8,000. So n. So that now our p say 2%, 0.02. So that our q equals 1 minus p, okay, which is 1 minus 0.02. And in a calculator, 1 minus 0.02 can be, I think, 0.98, I believe. So I say 1 minus 0.02 is 0.98. So we have it here as 0.98. 0.98. So with this, we are ready to answer the question. I'm going to move this to next page so that we have enough room to solve this. Okay. So mean, we know the formula, so I'm going to take you to the next other workbook. So you can see the mean equals. Before we go there, let me. Well, I think I have it on paper. So the mean of this will be 8,000. Okay. Mean, I have 8,000. N is 8,000. P is 0.02 and Q is 0.98. Okay. So that the mean becomes equals n times p, n times p, it means 8,000, okay, times 0.02. This we can have in decimals. So 8,000 got 8,000 times 0.02 give us 160. Okay, 160 bets result to twins, which is 160 bets. 160 bets result to twins. So I'm gonna copy this. Okay, and put it on our main workbook so you can see it. That becomes our mean. So 160 bets result to twins, 8,000. See? Now, variance. Let's get the variance. The variance is variance equals n times p times q, which means 8,000 times 0.02 times 0.98. And that gives us I'm going to take you so you can see it. So 8,000 times 0.02 then times 0.98, 156.8. 156.8. Nobody almost done 156.8 bets. So 156.8 bets is what we have for the variance. 156.8 here for the variance. And the standard deviation will be the square root of that. But to say the square root of variance, will give us the square root of variance will give us the standard deviation. So let me write 156.8 down. Square root of 156.8 will give us the standard deviation. So we have that the square root of, that's standard deviation equals square root of the variance okay, which is the square root of 156.8. 156.8 equals, and now we can get it from Desmos calculator. So you have 150 square root of 156.8. 156.8 is 12.5. 12.5. Okay. 12.5. I wish we have. I'll put it in the work our main workbook, and that will become here 12.5. So in summary, according to these calculations, the mean is 160, which is the average of 160 bets per every 8,000. Out of 8,000 bets, 160, an average of 160 result to 20. That's what it means. And our variance is 156.8, and then the standard deviation is 12.5. Now, if you don't have any, if you have any question, you can ask. Otherwise, if you don't have any question, then let me just take your names and we can leave. I am all ears. 4781. So let's see who are here. I have Aaron is here. Chambers. I got Ania. Got Taylor. All right. If you don't have any question, then you can feel free to leave. But if you have, you can ask.
Professor, I have a question about my attendance. On what was that? On Monday, I had came to class, but it was 3:50 and I had to leave because I had to go to work, and you marked me as absent.
You came on Monday?
Yes, I was in class on Monday. I just had to leave at the scheduled time, and class was supposed to be over because I had work.
In that case, next time, just send me an email after you left the class so I can know. Okay?
Okay, so are you?
So what's your name again? It's Ania, right?
Yes.
So I'm gonna go and fix it.
Because on Canvas it's at a 92 out of 100.
I'm gonna fix it. So next time, send me the email that you have to leave because of your work. Okay?
Thank you.
So you're welcome. So Ania, right?
Yes.
I'm gonna
have a good one.
Bye-bye.